Okay, so number 20 in 5-3. All right, so P, Q, R, S, and T, U are each perpendicular to U, and R is the midpoint of PD. And you want to make the S is R is equidistant to U and Q. Okay, so make these equidistant. So this is a perpendicular bisector. Okay. All right. So I don't know. I think we're gonna run out of space, or we can make a paragraph proof. Oh, okay. All right. So one, PQ, RS, and TU perpendicular to UQ given, and two, TU is parallel to RS, is parallel to PQ, and lines perpendicular to the same lines are parallel. And three, R is midpoint of PT given, and four, let's see what exactly the proof says here. If the three parallel lines cut off a congruent segment on one transversal, then they cut off a congruent segment on every transversal. Okay, so we have to make them congruent. All right, so that means TR is congruent to PR, and that would be definition of midpoint. Okay. So then you can say that US is congruent to QS, and three, what was it exactly? Let's see here. The three parallel lines cut off congruent segments on one transversal, then they cut off a congruent segments on every transversal. Okay, so three parallel lines cut by transversal form two congruent segments every transversal forms congruent segment. Okay, so these are congruent, and so sex RS is perpendicular. Well, actually, yeah, RS is a perpendicular bisector of UQ. That's the definition of perpendicular bisector, because these are the same segment and the lines are perpendicular, so that's a perpendicular bisector. So then 7, R is on perpendicular bisector of segment UQ, and I don't think we need to say this because we're saying RS, so that's fine. RS is a perpendicular bisector. So then R is equidistant distance from U and Q, and if a point is on a perpendicular bisector of a segment, then it is equidistant to two end points of the segment. Okay.